Welcome back, students. This video is to help you with your ALEKS assignment over solving systems of inequalities. So systems, meaning not just one inequality, but two inequalities. Before I begin, I just want to congratulate you. This is our final assignment for the first semester, besides your semester review. And thank you. I guess I should say thank you for making it along the way this far. All right, so this systems, notice that there are only 4 questions on this assignment. Don't get too excited about that. It just means that there's going to be a little bit more work involved when it comes to solving by graphing the system of inequalities. All right, so notice that there is a graph on question number 1 for you. That's because you are going to graph both of those inequalities. So the nice thing about question number 1, so on your work page, please make sure that you put your name and put your block and put which assignment this is. And then on question number 1, you need to write down both of your inequalities on that work page. So y is greater than 2x minus 5. You're also going to have y is less than or equal to negative 5x minus 4. The nice thing about this question is that these are already solved for y. So when you compare both of these to the formula y equals mx plus b, you can go straight to identifying your slope, m, as being the number in front of x. So for me, mine would be 2 over 1 for my first inequality. And for my second inequality, my number in front of x is negative 5. So that would be negative 5 over 1. Then you identify the b, which is the number directly after x. So after x, I see a negative 5. So this is going to be negative 5. And after this x, I see a negative 4. Another thing on your work page to include would also be, are you going to use a solid line or a dashed line? So for my first inequality, since it's just greater than, I'm going to use a dashed line, which means that these points that I'm about ready to graph would not be a part of the solution. But this one says or equal to, which means I'm going to use a solid boundary line. All right, so then I'd come over here and I'm going to get my line tool and I'm going to have to graph both of these lines. So my first line has a y-intercept at negative 5. So I plot my point on the y-axis at negative 5. And then I move using my slope, which is positive. So I go up 1, 2, and then I always move to the right. So I go to the right by 1. I need this line to be dashed, so I'm going to get my dash tool and click on my line, and now it becomes dashed. Now I'm going to click on my line tool again, and I need to graph my other line, which has a y-intercept at negative 4, and this slope is negative 5 over 1, which means I'm going to go down 1, 2, 3, 4, 5, and I'm going to move to the right by 1 and click and make my point. Had I run out of room that way, I could have done the opposite, and I could have gone up. I was starting here. I could have gone up 1, 2, 3, 4, 5, and moved to the left by 1. All right, that one, I want it to be solid, which it automatically starts off as solid, and that means that it's good to go. All right, now, I'm not finished with this. Notice that when I have 2 lines that are graphed, it takes the coordinate plane, and instead of separating it into just 2 sections, there are 1, 2, 3, 4 possible sections. All right, so what I'm going to do first, I still need to do a test point. So what I'm going to do first is I'm going to pick any point that's not on either of my lines, and I'm going to plug it into my first inequality. It doesn't matter which one you choose, but pick any point that you want that is not on your line, and you're going to plug it into your first inequality. All right, so my first test point that I'm going to choose, like I said, it really does not matter what you do. I think I'm going to do 1, 1. So here's where 1, 1 is located. All right, so I'm going to do 1, 1, which means my x is 1 and my y is 1, and I plug it into my first inequality. So my first inequality is y is greater than 2x minus 5. So I'm going to replace y with 1 is greater than. I'm going to replace my x with 1, so 2 times 1, and then minus 5. So 1 is greater than, 2 times 1 is 2, and then 2 minus 5 is negative 3. Is that true or false? And in this case, it is true. Had it been false, I would have had to choose a new test point. Okay, but we'll talk about that on a different one. On this one, this case was true. All right, so now what I'm going to do is I'm going to take my same ordered pair and I'm going to plug it into my second inequality. So my second inequality is y is less than or equal to negative 5x minus 4. So I'm going to replace my y with 1 is less than or equal to negative 5. I'm going to replace my x with 1, and then I have my minus 4. So this gives me 1 is less than or equal to 5, or negative 5 times 1 is negative 5, minus 4 is negative 9. So is 1 smaller than negative 9? Well, no, that's false. All right, so this is the tricky part. Getting the boundary lines graphed should be pretty easy. Okay, it's just not just graphing just 1, but you're graphing 2. The tricky part is trying to get this test point and trying to figure out where you are going to graph. Okay, where are you going to shade? All right, so for my first line, my first inequality, that was the 2x minus 5. That was the dashed line. So pretend like you only see this dashed line right here. All right, that one was true. So that means 1, 1, I would have been shading on this side. All right, so notice that both of these regions right here, had my other line not been there, both of these would have been graphed. Both of these would have been shaded. But then for my second inequality, okay, let me actually go ahead and label these. So this is region 1, this is region 2, which is where I chose my test point from. This is region 3, and then down here is region 4. All right, so what my first test point is telling me is since 1, 1 is true, and here's my dashed line, here's 1, 1, it means that region 3 and region 4 are not possible regions for our solutions. But for the second line, okay, the second inequality, I got a false statement, which means that if I were to plot where 1, 1 is, it would be false. So instead of being in region 2 where this is, it means by process of elimination, I'm going to be shading over here in region 1. All right, so all of your work would be done on your work page. So I'm going to go ahead and clear my writing. I'm going to go ahead and get my shading tool, and then I'm going to click over here where I decided my shading is going to be. Please check your answers to make sure it is right. It's very easy to mess up on this. Okay, and it will tell you if you've got it partially correct or not. It should tell you if your boundaries are correct, and same with your shading. The shading is going to be kind of tricky. So let's go through and let's do another question together. The nice thing about these homework assignments is that you get 3 attempts on them. So if you mess up the first time, you get to try it again. Before you do that third attempt, I'm going to highly suggest that you reach out to your algebra teacher and you ask for some help if you need that help. All right, so another example works pretty much the exact same way. Okay, both of my equations are already given to me in y equals mx plus b form. So I'd go ahead and on my work page, I'm going to write down what those 2 inequalities are. If I said equations before, I apologize. These are inequalities. Again, they're already both solved for y, so I'm going to use that y equals mx plus b. And I'm going to identify my m for my first inequality to be negative 3 over 1, and my y-intercept to be positive 4. For my second inequality, I'm going to identify my m to be positive 2 over 1 and my y-intercept to be negative 7, because that number directly after x is a negative 7. Also on my work page, I should identify dashed or solid. In my first inequality, I'm going to have a dashed boundary line. In my second one, it's going to be solid. Why? Well, because this one had an or equal to, and this one is just less than. All right, so then I'm going to graph these lines. These are called my boundary lines. So my first boundary line has a y-intercept at positive 4. Whoops. So I plot my point at positive 4 on the y-axis, and then I move from there, negative 3, so I go down 1, 2, 3 into the right one. I need this to be a dashed line, so I'm going to get my dash tool and click on it. Now I'm going to graph my second boundary line, which has a y-intercept down at negative 7. So on the y-axis at negative 7, I plot a point, and then my slope is positive 2 over 1. So I'm going to move up 2 and to the right one, and there's my boundary line. All right, so now notice, okay, and this is why it'd be helpful to have this on your work page. Notice that there are 1, 2, 3, 4 possible regions for where these solutions could lie. So what we're going to do is we are going to choose a test point. We are going to choose any test point that we want, and we are going to plug them into the first inequality. And then we're going to plug it into the second inequality, or we're going to see. We're going to have to plug it into both at some point. All right, so a test point goes into both at some point. What is that test point going to be? It does not matter. You get to choose as long as it's not on any of the lines. All right, so for this one, I think I'm going to go ahead and it's easier to work with positive numbers, so I think we're going to go ahead and use the test point 3, 3. All right, so here's 3, 3 up in, okay, my second region up here. So I'm going to plug in 3, 3 into my first inequality. So y is less than negative 3x plus 4. So I'm going to replace x and y both with 3. So I replace my y with 3 is less than negative 3. Oh, there's x. I'm going to replace it with 3 and then plus 4. So this gives me 3 is less than negative 3 times 3 will give me negative 9 plus 4. So is 3 less than negative 5? Is that true or false? Well, that one's false. All right, so because this is false, it's telling me that region 2 is not where my solutions lie. Okay. Also, here's my dashed line. So pretend like the only line that's here is my dashed line. If you wanted to, I guess I could have held off on graphing my solid line. Okay, but here's my dashed line. 3, 3. Okay, it means that based on this dashed line, this region 3 is also on the same side of the dashed line. So here's my dashed line. It means that region 2 and region 3 cannot be where my solutions lie. All right, so now what I need to do is I need to pick a test point. I need to change my test point. Since I know 3, 3 doesn't work, I need to change my test point. I need to either pick something from region 1 or I need to pick something from region 4. I'm not going to choose one from one of the regions I already eliminated. All right, so I think I'm going to go with, let's do negative 1, negative 1. All right, so negative 1, negative 1 is my new test point. So TP, not toilet paper, it's my test point. All right, so TP, my test point, negative 1, negative 1. Plugging this into my second inequality, I'll replace y with negative 1 is greater than or equal to 2. I'll replace x with negative 1, and then I have minus 7. So negative 1 is greater than or equal to negative 1 times 2 is negative 2. Negative 2 minus 7 is negative 9. So is negative 1 greater than or equal to negative 9? Well, yes, this one is true. Don't get tripped up by those negatives. The closer you are to 0, the bigger it is. All right, so negative 1 is greater than negative 9 is true. Had it been false, I would have crossed out where region 1 is, and I would have had 4 be where my solutions lie. But since it's true, it means that this is where my solutions will be, which means that region 4 is out. All right, so what I'm going to do is I'm going to go ahead and all of this work would technically be on my work page. So I'm going to clear it from my screen. I'm going to get my shading tool, and I'm going to shade where negative 1 was. And then I'm going to check my work to make sure it was right, because it's very, very easy to make a mistake on these questions. And if once I get that correct, it's a good sigh of relief and move on to the next question. Thankfully, again, there are only 4 questions. All right, so question number 3, very much the same as question numbers 1 and 2. All right, so question number 3, if you need help with it, again, I'm just going to do another example. If you don't need this, fast forward and go to question number 4 if you need help with question number 4. What I'm going to do is I'm going to go ahead, I'm going to write down both of my inequalities. Okay, and I'm going to write down, since they're both solved for y, I'm going to identify their slopes. So this would be on my work page. The number in front of x for this first one is 3, so putting that as a fraction, it's 3 over 1. The number directly after x is negative 5, so my y-intercept is negative 5. For this line, my m, my number directly in front of x, is negative 3. So writing that as a fraction, that's negative 3 over 1. And my y-intercept, the number directly after x, is negative 7. Also on my work page, I should identify that my first boundary line, I think this has happened on all of mine so far, my first boundary line is dashed and my second is solid. Okay, the reason I know that is because this just has greater than, this one has an or equal to. So if you have that or equal to, then it's going to be a solid boundary line. So I'm going to graph both of those. So my first boundary line is at negative 5 for the y-intercept, and then it moves 3 over 1, so up 1, 2, 3 to the right 1. And I need that to be dashed, so I'll make it dashed. Get my line tool again. This boundary line has a y-intercept down at negative 7, and it moves negative 3, so 1, 2, 3, and to the right by 1. This is a solid line, so I'm going to leave it as solid. All right, hopefully that's the easier part. This is the trickier part. The fact that we have 2 lines that divide it into 1, 2, 3, 4 regions. All right, so test point is what we use to decide where we are going to shade. So pick any test point that you want. I think so far all of my test points have come from region 2. So I'm going to go ahead and change this a little bit because you get to pick whichever test point you want as long as it's not on a boundary line. I think I'm going to use this one from region 3, 10, 0. All right, so here's my x, here's my y. So my first inequality, instead of writing y, I'm going to replace it with 0 is greater than 3. Instead of writing x, I'm going to replace it with 10 and then minus 5. So this is going to give me 0 is greater than 3 times 10 is 30 minus 5 is 25. So is 0 greater than 25? Is that true or false? That one's false, which means that region 3 is not where a solution is. If you're confused on this next part, do a test point for each region and see if it's true for both of your inequalities. Okay, here's how I like to do it. Since that one was false and I was using my dashed line, here's my dashed line. What region is also on the same side as region 3 compared to this dashed line? Well, that's region 4, so I'm going to throw region 4 out. It's not a possibility. Now what I'm going to do is I'm going to switch my test point and either pick it from region 1 or region 2. Let's go with 0, 0. All right, so 0, 0, this is my new test point. This is coming from region 2. So I'm going to plug this into my second inequality. I replace my y with 0 is less than or equal to negative 3. I replace x with 0 and then minus 7. So 0 is less than or equal to negative 3 times 0 is 0, minus 7 is negative 7. All right, so this is opening up towards negative 7, which is saying that negative 7 is larger than 0, which is false. So because this is false, it means that region 2, which is where 0, 0 lies, is false. That means that region 2 is not a solution. It's not where my solutions lie. So that means that my solutions lie in region 1. So I'm going to click over here in region 1 and it shades. Okay, all of this work would be on my work page. And on ALEKS is where I just have my graph. And then I click and check my answer. And I hope that it's right, and it is. And if it wasn't, I'd go back and I'd check my work and fix whatever it is that I might have messed up on. All right, but final question, the one that involves the most work, okay? And the reason why this one involves the most work is because when it comes to graphing our inequalities, we need to have them in this form, y equals mx plus b. And both of these inequalities are negative 5x plus 3y is less than or equal to 6, and 5x plus 7y is greater than 21. Those are in what's called standard form. We need to solve for y. So first thing we should do is move the minus 5x to the other side. So the opposite of a minus 5x would be to plus 5x on both sides. Minus 5x plus 5x cancels out. That leaves me with 3y is less than or equal to. I'm going to bump the 6 over and put in the 5x. And then that 6 is positive, so I'll put plus 6. Then y is being multiplied by 3. So the opposite of multiply is divide. So I'm going to divide everything by 3. And this is going to give me, can I fit it? Yeah, I can fit it right here. Y, and then since I was dividing by a positive, it means I keep the same inequality symbol. So y is less than or equal to, and then I have 5 over 3. I can use Desmos to simplify, but that one doesn't. And then positive 6 divided by positive 3 is positive 2. All right, so what this is telling me is that my y-intercept and my slope, okay, my number in front of x is my slope. My slope is positive 5 over 3. And my y-intercept is positive 2. All right, so I can graph that line. Before I do, I'm going to note that this one's going to be a solid line because it was or equal to. So I'm going to go ahead and I'm going to get my line tool, and I'm going to graph my y-intercept at positive 2, and my slope is positive, so I'm going to go up 1, 2, 3, 4, 5, and to the right 1, 2, 3. This needs to be a solid line, which it is. All right, my second inequality, I'll need to do the same thing. So I'll need to move 5x to the other side. Right now, that one's positive, and the opposite of a positive is a negative. So I'm going to minus 5x on both sides. That's going to leave me with positive 7y is greater than minus 5x. I'll put that in there, and then I'll bump the positive 21 to the end. Y is being multiplied by 7, so the opposite of multiply by 7 is divide by 7. 7 divided by 7 cancels. This gives me y is greater than Negative 5 over 7, use Desmos to see if it can simplify. It doesn't, so I'm just going to rewrite this as minus 5 over 7, keep the x with it, and then positive 21 divided by positive 7 is positive 3. So in this case, my m, my slope is negative 5 over 7, and my b, my y-intercept, is positive 3. So I'm going to go and get my line tool. Oh, I guess before I do that, on my work page, I should state that this is going to be a dashed boundary line because this was just a greater than symbol. All right, so now I'm going to get my line tool, and on the y-axis, I plot a point at 3, and my slope is negative, so I'm going to go down 1, 2, 3, 4, 5, and to the right, 1, 2, 3, 4, 5, 6, 7, and plot my point. This one needs to be dashed, so I'm going to turn this to be dashed. All right, last part. We have our 2 lines that has divided our coordinate plane into 1, 2, 3, 4 regions. We need to figure out which region has our solutions. All right, so 1 in 4 chance of guessing correctly. You only get 3 attempts at this, so I suggest that you don't just guess. So how are you going to get this without guessing? Well, you are going to use that good old TP, that test point. So pick any point that you want from any of these 4 regions. It does not matter which one you use. Probably one of my most favorites, and again, as long as it's not on a line, it's okay to use. One of my most favorites is 0, 0, the origin. So here 0, 0 in this example is in region number 4. So I'm going to plug this into my first inequality. I always go back to my originals. So my original inequality is negative 5x plus 3y is less than or equal to 6. So I'm going to replace x and y with 0. So negative 5 times 0 plus 3 times 0 is less than or equal to 6. So negative 5 times 0 is 0. 3 times 0 is 0. So 0 is less than or equal to 6. Is that true or false? Well, this is opening towards the 6, which is bigger than 0, which makes this true. All right, so that means that region 4, this came from region 4. Region 4 is a possibility for where our solutions are. Okay, I was comparing this to my first inequality. My first inequality is the solid line. So here's my solid line. What is the other region that is on the same side compared to the solid line as region 4? And that's region 3. So region 3 or region 4 are where our possible solutions lie, which means that region 2 and region 1 have been eliminated. All right, now what we're going to need to do is we are going to need to plug, since this is still good for us, 0, 0 is still a possible solution, I'm going to now take my same test point and I'm going to plug it into my other inequality. I'm going to work right here because I've run out of room everywhere else. So this inequality, my second one, is 5x plus 7y is greater than 21. So I'm going to replace x with 0, and I'm going to replace y with 0. Is that greater than 21? So 5 times 0 is 0, 7 times 0 is 0, so 0 plus 0 is 0. Is that larger than 21? That is false. So here's where 0, 0 is. It now is false, which means that region 4 is no longer a possibility. Region 3 is where my solutions are going to lie. So I'm going to get my shading tool, and I'm going to click somewhere in region 3, and I'm going to check my work, and I'm going to hope that it is correct. Oops, it's not, because I didn't scroll down all the way, and apparently there's more to this question than what I did. A point in the solution set. All right, so one last thing is I need to type a point that is in my shaded region. It can be any point that I want that's in this shaded region. So let's go ahead and go this point right here, which would be at 10, 1. All right, now I'm going to check my work and hope that I get this one right. And it tells me that I'm correct, which means that, yes, I have finished all of this. If I would have missed something, I would have gone back and corrected my work. All right, but now I'm finished with this homework assignment, which means that I'm finished with all of the regular homework assignments for the first semester of Algebra 1. Congratulations.